Hey guys, welcome. So in this video I'm going to show you how to use Euler's method to estimate solutions to differential equations. I'm going to talk big picture because in practice what you actually do is a lot of number crunching. I already made a video on using Taylor polynomials to estimate solutions to differential equations, and there I gave you a little preview of Euler's method because we talked about the difference between the two. And Taylor polynomials, as the name says, uses polynomials, which are curves, and there in that video I said that Euler's method uses little lines, right, with steps, and we'll talk about what that looks like exactly in this video. But I do want to correct one thing, which is that like lines in math are called curves, so really it's like polynomials versus linear equations, right? Okay, that's the difference. All right, now with that said, may the Lord Jesus Christ bless this video, bless you and I, and let's get started. All right, now let's start with this visual where y is the curve in blue, and that's the function that we don't know, right? But we're given a differential equation, so we're given the equation of the slope of y, right? And you know, I said stuff because it could look like a lot of different things. It could be x squared plus y squared, or it could just be a function of x, or yeah, you get it. And then in addition to the differential equation, you need to be given an initial point on y, so let's call that x0, y0, and then you need to be given a step size or a step length, because what you're going to do is you're going to basically use little steps of little lines to approximate the curve y, and again we'll talk more about that in a second. But yeah, the point is that in addition to this initial point on y, you also need a step length or a step size. So I'm just going to go with step size instead of step length. And in this case, let's say that our step size is a, right? So we have that. And so where to from here is the question, right? Okay, so this is what we do. We know that we've got like x0, y0, let's say, is right here. So we have x0, y0 to start. And what we're going to do is we're going to write an equation of the tangent line at x0, y0, because we have the slope given by here, and we have a point. So in point slope form, the equation of the tangent line is going to be y minus y0 is equal to m times x minus x0, where m, right, is equal to dy dx evaluated at x0, y0, right? That's how we get m, and the other thing you need for this equation of the line is the point, which you already have, right? Okay, and what this line is going to look like is something like this. It's a tangent line, right? And of course it goes on forever, this line, right? But we're not going to use it everywhere. We're only going to use it to take our step size of a. So we're starting with an x of, if we project this point down to the x-axis, we're going to start with x0. And so the number of steps we take to get to b is going to be, it's going to clearly depend on our step size, right? And so, but it's going to be b minus x0 divided by a. This is how many steps will be required, right, to estimate y of b, and that's what we're after, right? Clearly, we're trying to estimate y of b. So the question here is like, what is y of b? That's the goal, right? All right. And so let's say that like a, our step size is of this length, like here. So a is this distance, right? So it looks like if figure is drawn accurately that I'll need 3 a's to get to b, right? So this little guy is also a. This may be like a little early, but whatever, like I don't need to be that precise. You get what I'm trying to do. So this is little a and this is little a, so we need 3 of them, it looks like, based on this visual. And my bad, I'm like really annoyed that this a is like pretty tiny. Now it's too big. All right, that's all I'm gonna be doing. No. All right, so now what? Well, what we want to do is land on this line here, right? That's because this point here is x0 plus a, right? And so we're going to use this first line just to get to there, right? And so what is that point? What are its coordinates? First of all, we're going to name it, this point, we're going to name it x1, y1, right? And its coordinate is going to be like this, right? Well, its x coordinate for x1, y1, x1, y1, well, I might need more space, but yeah, x1, y1, its coordinate is going to be, well, x1 is going to be x0 plus a, x0 plus a, right? And then what's y1 going to be? Well, first, let's get y by itself in this equation. And y is going to be m times x minus x0 plus y0. So from here, to get to y1, we need to plug in x0 plus a into the equation of that red line, which is this equation. So if we plug in x0 plus a into x here, we're going to get that y1 is going to be m times x0 plus a minus x0 plus y0. Now, it was pretty intuitive to understand that x1, right, is going to be, well, the x we started with plus a, right? Okay, that made perfect sense. And it's going to make perfect sense why y1 has got to be this in a second. So first, this implies, right, this implies that, I don't want to go off grid. So this implies that y1 is m, x0 minus x0 is nothing. So ma and then plus y0, right? All right, now to easily understand why y1 has got to be this, just like how you easily understood x1 has got to be that, let's look at this, which is like, let's draw, I guess, in blue, whatever, like, but no, the coordinate axes are in black. Okay, so too many choices. All right, so let's draw this, and let's look at a line that goes through the origin, right? A line that goes through the origin, so that it's easy to understand what's going on. Sorry guys. So a line that goes through the origin. So let's say that line is like this, right? No, sorry guys. Okay, I'll live with this, don't worry. So the equation of this line would be like y equals mx, right? Not the same y as that, obviously, but like it's y equals mx. Fine. Well, if I went a amount here, right? It's just easier if we go through the origin to understand. If this is a, well, that's the change in x from this to here. What would the change in y be? Well, the change in y would be like this distance here, and that's m times a. So that's exactly what y1 should be. It should be the starting y0 and then the change in y, which would be like, it's pretty hard to draw here, but the change in y would be m times a. So the starting y at plus m times a should give us the new y, and that visual should aid you in understanding that. Okay, but after this, it's kind of like silly, trivial to do the rest of it. What you're going to do is now use x1, y1 to write a new equation. Of course, for the new equation, the new slope is going to be dy dx evaluated at x1, y1, right? But otherwise, you have the point. So you basically repeat exactly what we did. But yeah, before I forget, let me write the y coordinate y1 here, which is y0 plus ma, right? Okay, cool. But yeah, like, yeah, you have the slope and a point for this new guy. So you're going to get a new tangent line. Well, it's not going to be a tangent line, but you get it. It's going to course correct for you. So it's going to look like that. And then you're going to use it to create a new point here. And exactly the same way as we proceeded about going from x0 to y0, you go from x1 to x1, y1. X0, y0 to x1, y1 is how we got here. And then now you get to directly above here to a new point x2, y2, and you do it one more time, and that's going to give you a very good estimate of y of b. And let me at least give you the visual of what that would look like. It'll look like this, something like this, right? And so what you're trying to get to is like a point like right here. Yeah? Okay, cool. All right, so before I leave, a message which is like one of the best news that I heard this year is Bruce Jenner's house burning and him having to flee, because, well, I prayed on that because you know, like, there are people who follow Jesus and Allah, which are awesome people, and then there are people who follow Satan, and the Satanists mostly believe in Baphomet, which has male and female parts. And so there are people who actively try to pollute kids, pollute Christians, and destroy like this beautiful world that we live in. And Bruce Jenner is from those people. I support and love transgendered people. In fact, one of my favorite bands is Lower Dens, which I think is headed by someone who's transgendered. But people like Bruce Jenner actually mock transgendered people. They don't stand for transgendered people's rights. And so I hope everybody who follows Satan dies off like as soon as possible. And if I had it my way, I'd take a shotgun and shoot Bruce Jenner in the face. But, you know, I can't do that. So for now, I'll pray on it. And may you pray with me and with the rest of us Christians and Muslim people. So those of us who follow, you know, who are spiritually secure and do not follow Satan, may we prosper and may they all fucking die off. Oh, sorry about my French. May they all die off.